Hello everyone, welcome to my channel. Today we'll try to understand volatile variables in simple terms. Imagine this. You are managing a shared family calendar. Your sibling, who is always rushing, updates that calendar with a note, dinner at Grandma's place 7 p.m. Friday. But when you check the document, you still see the old plan saying lunch at Grandma's place 1 p.m. Friday. Now you arrive at lunchtime and you find out it was dinner that was planned and not the lunch. It's frustrating, right? And now why did this happen? Because the updates weren't properly synced or visible to everyone in time. Now, let me show you how concepts in programming like volatile variables and synchronized blocks ensure this never happens in a well-designed multi-user system. First, let's talk about volatile variables. Now we'll take an example of Google Doc, where if there are any updates made, it will reflect instantly whenever someone makes a change. When person A updates the dinner timing, volatile rules ensure that everyone else, like person B, sees the update right away before doing anything else with that information. In programming, we call this a volatile write followed by a volatile read. In technical terms, if I have to say this, it will be a volatile write happens before another volatile read. It's a fancy way of saying that once thread 1, that is person A, writes something, thread 2, that is person B, will see the latest value. No delays, no outdated information. Now, let's move to synchronized blocks. This concept is like putting a lock on a room where updates happen. Imagine that instead of writing directly on the Google Doc, person A goes into a private room, updates a sticky note with a new plan, and locks the room when done. Now, person B comes along, unlocks the room and sees the updated note. The rule here is an unlock happens before another lock. This ensures that when thread 1, that is person A, finishes their work and unlocks the synchronized block, any thread that enters afterwards, for example person B, sees all the changes made inside. So how does this all fit together? When thread 1 writes to volatile variable or unlocks a synchronized block, all the changes it made before these actions will visible to the other threads. Now back to our Google Doc example. If person A makes updates like changing the dinner timing or adding grandma's address, these updates are guaranteed to be visible to person B after a volatile read, looking at the updated doc, or a synchronized lock. For example, entering the locked room where updates were made. Now we'll just try to understand the things which we have to remember, like the tricks which will help us to remember. Here A stands for no atomicity, does not provide atomic operation, so it's not suitable for compound actions like increment. T stands for threading, as volatile variable ensures thread safety. I stands for instance variable only, no methods or classes, it will not be applied to those. L stands for latest value, ensures thread always read the latest value of a variable directly from the main memory. That's all from the volatile variable perspective. See you guys in the next video to understand this from the code perspective. Thank you.